Hey guys, continuing on from where we left off today in class, we're going to continue our work with complex numbers. And to finish up basically this entire unit, we're going to look to add and subtract these types of numbers, and we're going to also look to graph complex numbers. So hopefully you remember from class how similar multiplication was to multiplying binomials algebraically. Well, what you're going to notice today and with this lesson is that adding and subtracting complex numbers is basically your same skill sets of adding and subtracting algebraic expressions that you've learned in the past. So with that, a pretty simple concept here for adding and subtracting is basically that we are going to combine like terms. But this time, our like terms are the two components that make up a complex number. We're going to combine the real numbers, and we're going to combine the imaginary units to create a new sum or difference of our complex numbers. And the one thing with subtraction, which is identical to algebra, is that we're going to look to distribute that -1 value before combining like terms. Again, all of this is identical to what you know from algebra and adding and subtracting algebraic expressions. So basically, to quickly see the concept in these two examples, here's how easy it really is. When adding, you guys don't have to worry about any distribution or anything, so we're going to keep it nice and simple. Real numbers get combined with real numbers. Our imaginary unit gets combined with the imaginary unit. And there's your final answer. Everything in A plus BI form, as we spoke about in multiplication and division. And there it is. Simple and straightforward. Combine like terms like you did in algebra. Same holds true for multiplication. Subtraction. The only difference, as we've seen in algebra, is that -1 coefficient in front of the second binomial. So we're going to distribute that -1, creating our expression of 2 minus 4i. And from there, we're just going to do exactly what we did before. Real number gets combined with the real number. The imaginary unit gets combined with the imaginary unit. And that's it. That's all there is to it. Your final answer, again, making sure it's in A plus BI form, is -1 minus 12i. So hopefully, guys, you can see how easy this truly is. In adding, combine like terms, just like you did in algebra. In subtraction, distribute that -1 just like you did in algebra. Combine the real to real and the imaginary to the imaginary, and you are done. Now, as far as graphing is concerned, this is actually just as easy as well. Hopefully you remember that when you graphed a coordinate back in algebra, you would have an x and a y value. So if we wanted to graph the point -3, 2, we know that we would go left 3 units on the x-axis, up 2 units on the y-axis, and we'd be able to plot that point of -3, 2. Again, stuff you guys already hopefully remember or just needed a little refresher of. Well, for complex numbers and graphing them, the process is almost identical. The difference being, instead of an x and a y axis, we actually have a real axis and the imaginary axis, or an A and a BI axis, if you would. And the way you guys are going to graph these numbers is basically the same way you would graph a point. For example, the complex number 3 plus 4i that we see in the first example means we're going to go right 3 units on the real axis and up 4 units on the imaginary axis. So we then create the point, or the coordinate, 3 plus 4i. Again, in real and imaginary space. The only difference with complex numbers versus normal points on an XY coordinate plane is that we're actually going to draw what we call a vector line to that coordinate. All right? Basically, we're showing direction in which that complex number is moving on what we call the real and imaginary plane. All right? If we look at one more example, number 3 here, we have the complex number -4 plus 2i. As far as graphing that's concerned, we're going to go left 4 units on the real axis and up 2 units on the imaginary to create that same type of coordinate. Again, there is your -4 plus 2i complex number. But again, to show direction, we draw in that vector line, and that's it. That's all there is to it, guys. As far as your adding, subtracting, and graphing, very, very similar to things you've learned before, now just applying them to complex numbers. For graphing, in lieu of an x and y axis, we now have a real and an imaginary axis, or sometimes you see it referred to as the a and bi axes. And for adding and subtracting, it's 100% identical to what you've learned in algebra, combining like terms, reals to reals, imaginary to imaginary, and just making sure we distribute that coefficient of -1 to the second binomial in subtraction. Other than that, you've got everything you need for complex numbers between operations, powers of I, and everything for this whole unit. We'll look to test this with our next unit on quadratics, which will actually start the next day. So hopefully you've got all this. We'll look at it again tomorrow in class and practice it all together. Hope you guys have a great night. See you in the morning.